thank you everyone for joining us today. We've got Martin, who's our ever willing speaker, who's always with us. So thank you for doing a virtual session today, Martin. We do appreciate it. I'll hand over to you now to introduce yourself, and I will mute myself and disappear.
Okay, I'll introduce myself by saying the words Martin Packer, ever willing for now. I know most of you who haven't hidden behind the cloak of anonymity, and most of you know me, I'm pretty sure, but I've been doing performance for, as we like to say now, over 30 years on the mainframe, man and older man, I guess. So I might know a thing or two. And I've worked with many of you in the past, actually quite directly. I'm conscious that I have some customer data in this presentation, but I don't think any of you will be thrown under any bus, proverbial or literal, by the making of this presentation. And some of you will have seen earlier versions of this. None of you, I think, will have seen this version. So it's quite an old presentation, but it's been refurbished, as I like to say, several times over the years. Most notably this year, we're really updating it for some performance considerations on top of the capacity ones, system recovery boost, and I can't say ZCX, sorry about that, ZCX. So really the thesis of this is that people do less good job of capacity planning for zIIP, right, than they do for GCPs. And I think people really should take it very seriously indeed. So there's a certain amount of motivation to why you should take it seriously. And there's quite a lot about what to look out for and things that make you scratch your head and go, the game is changing on me. I'd better look at zIIP as a topic again. Feel free to throw questions into the chat. I've got, as I just said to Nathan, I've got the left-hand inch of the chat window visible to me. So I should see if people actually want to ask questions. And I'll try and take them as we go along, because I'm trying to pretend that nothing happened this year, but we all know how naive that is. Okay, so let's start with what I'm hoping you will remember, if you remember nothing else. So firstly, as I've said, capacity planning for zIIPs has become much more important over the last 10 years, I would think. And by the way, the first version of this presentation probably was 7 years ago, when my then manager, he didn't really set me the challenge, but he hinted that a challenge was there. So of course I grabbed it. We need to be very careful about what we think of as a full zIIP pool. It's different and probably less full in numeric terms than a GCP pool would be. We need to be looking at zIIP potential and actual usage down at the address space level and a little bit below, to be quite frank. We need to be thinking very carefully, as always, about LPAR configuration, especially carefully for zIIPs. And we need to think about new exploiters that can significantly change the picture when it comes to demand for zIIP. So those are the things I really want to get across in this presentation. Okay. So there's all sorts of reasons why people have tended to neglect zIIP capacity planning. Firstly, the obvious one is that zIIPs are much cheaper than general purpose processors. And they don't attract a software bill. So you'd be less inclined to worry about zIIP because of those two factors. It's also been a bit of a no-op until a few years ago in terms of zIIPs don't really run that busy. And if you run out of zIIP capacity, you can, in principle, always spill to general purpose engine, GCPs. And to be quite frank, sometimes it wasn't really the most carefully considered part of a purchase. And if you ignore zIIP, just like if you ignore ICFs and IFLs, then we've got a very simple, well, we haven't really, have we? But we've got a much simpler processor capacity planning and performance model to worry about, because we're down to a single general purpose engine pool. So those, in a nutshell, are the reasons why people have tended not to do zIIP capacity planning quite as well in the past as they need to. But here's why I think you should take it very seriously. firstly, if you spill to general purpose engine, then you're obviously using general purpose engine cycles, and that's going to, in principle, but not necessarily in detail, cost you money. Not spilling to a general purpose engine, whether at all or in a timely fashion, can cost you performance and, frankly, scalability. ZIIPs aren't actually free. And the next one's an interesting one for this year, and I guess this happens every 2 years. You know, putting another processor draw into a machine can be difficult or impossible. And the bit that's particularly this year's thing is I'm seeing a number of situations this year with Z13, and actually one we've just been dealing with EC12. You can't upgrade either of those. So if you need more zip, you know, you're going to be disappointed. And in fact, one of the situations I've been dealing with this year, it does desperately need more zip, but they can't have it. Actually, 2 of them do. You know, can't have it without replacing the machines. So sometimes the physicality or upgradability gets in the way of adding zip capacity in a way that really bites. The other point is more software that exploits zip is out there. Some of it, as we'll see, is more performance critical than the previous exploiters. Actually, that's quite an old statement, because I think most people are beyond DB2 version 10, which we'll talk about in this presentation. And some exploiters can have very big zip potential indeed, surprisingly large, as I learned in one case this year. New and modernized applications increasingly have zip eligibility. And one thing we're going to talk about a fair amount is LPAR configuration for zips actually affects their performance substantially. And I've seen situations where a failure to plan and provision capacity of any type, but including zip cases, can lead to outages. So there's lots of reasons why we should take zip capacity planning and performance and configuration pretty seriously. Okay, so I'm going to take this one very briefly, because I think we mostly know this and some of this is repeated. If you're DB210 or later, you need to pay a special attention to zip exploitation. And we have a bunch of slides, which I'm going to summarize for the purposes of time to make room for something else on that very topic. The bit that I really want to talk more about later on is towards the bottom, and it's really ZCX and system recovery boost have some implications that I think everybody needs to think through, particularly if they've got shiny Z15 with SRB, or even RP, which is the name I gather for recovery process boost. So we'll talk about some of these rather more than others. Well, I tried to give you a flavor of it's been a train that's been arriving for quite a long time with various new exploiters, at least from IBM, which really could change the game in step change ways that you might not necessarily expect. Okay, so let's talk about DB2 for a few minutes. So the key thing is that DB2 version 10 added zip support for deferred write and prefetch engines. And those are 100% eligible for zip. They have very stringent performance requirements. They really shouldn't be delayed. And in particular, crossover to GCPs really happens way too late to be helpful enough. This substantially changes the zip capacity planning rules in terms of what busy is and how you provision CPU to a particular workload. In particular, you need to treat DBM1 as a key address space and protect its access to CPU, including zip. You need to set its service class to use CPU critical, and version 11, which we'll come on to in a minute, makes the same thing apply to the master address space. Generally, people have classified master and DBM1 in the same service class. So the same protection should apply almost automatically to master as to DBM1. This slide is really trying to illustrate a point, which is you need to ensure that the goals you have for important work, in this case, think DB2 engine, really protect the work. And in particular, you need to understand the role of zIIP in goal attainment. So here is a service class called STC high. Along the bottom, we have how much of an engine the service class is using. Across, well, up the side is the velocity attained. The green line is the goal. So the goal says velocity of 70%. Now, across the operating range, we have data for here. And across the days, which is a different kind of blobs, we are consistently well above the 70% velocity in terms of what we deliver. You can see the line trending down, though, if you squint at the various blobs. So you can see a dynamic here that says as workload builds up, the service class velocity obtained is deteriorating. Maybe it's not terrible, but it's heading down towards the goal. So the recommendation we gave the customer was, firstly, this is a mixed DBM1 master and a few other things service class. So really we want to pull out DBM1 and master into something we would call, let's say, STCV high, and give it a goal that's actually closer to what it's achieving. So kind of 90 seems a reasonable number here. By the way, for DBM1 and master service classes, if you're achieving up in the 90s, it's probably it's probably using IO samples that are driving you up there. So this is quite a nice illustration of what happens if your goal actually isn't protective because the velocity drifts down as push comes to shove. Okay, we'll come back to that actually in a little bit. So version 11, as I say, exploits zIIP still further. The main one is the bit in blue. So log write and log read is all done on another dependent enclave SRB and is thoroughly zIIP eligible. So here, you know, master, you really don't want to slow down logging, whether writing or reading. And by the way, one of the recent situations I've been involved in, this has been a key factor in SAP performance because it does an awful lot of logging and its dependence on zIIP is pretty high. So version 11, you have to think about master as well as DBM1. But as I said, probably this is taken care of because you hopefully have master and DBM1 in a nice high service class. Version 12, I don't really want to pick anything out of this, but there's still more zIIP exploitation in DB2 in various places. So the picture is increasing zIIP exploitation by DB2 engine. Okay, so let's get into instrumentation. We spent almost a quarter of an hour talking about motivation here. There are many sources of information on zIIP, and they come from RMF, and they come from ZOS itself. We probably won't talk about, well, we will talk about SMF30 in a bit, and it comes from the middleware. So in DB2 accounting trace and Kick statistics trace, you will get some zIIP related metrics. I will note, and I don't think we're going to spend any time on this, SMT adds considerable complexity to the metrics, and one of the prime exploiters potentially of SMT2 is zIIP. IFL really being the other one. And by the way, IOPs are, as of Z14, they're 100%, well, they are SMT2, even though they're not zIIP or IFL. I actually have a blog post on that one, but we'll move on from there. Okay, so at the machine level, from type 70 record, subtype 1, you can see how busy the pool is. Actually, one of the tricks I like to say is I'm going to guess that the 1st and the 31st are the weekend. But basically, I'm going to use a term here which I quite like. I seem to inject words like slushing and hiatus into the lexicon here. There's a bundle of utilization series here, right? So basically, there's quite a lot of variety, even if the overall pattern is the same from day to day. But on the 2nd, which I'm going to guess here is a Monday, It's slightly higher than it was on the Friday, I think it was, which is the 30th. But anyway, you can see the pattern here is repeated, but some days are peakier than others. So maybe on the 2nd of the month, you need to pay a special attention. But this pool doesn't peak, at least an RMF sunrise at the 1 hour level, above about 50%. It almost certainly will be peaking significantly higher if you zoom in on the data. But in order to make this actually consumable, we tend to graph at 1 hour at a pinch quarter of an hour level. So you can see how busy the overall pool is. We can now take it down again from partition data report data in 70 subtype 1 into how busy each individual LPAR's use of the pool is. So in this case, sys-C is the big driver here, and sys-B and sys-A, not their real names, are less significant. So that you can get down to the LPAR level with type 70. Then you can break down the zIIP usage by service class or report class from 72 subtype 3 workload activity report data. And just for a change, I've actually thrown in the crossover numbers here. So this is zIIP eligible running on a general purpose engine in one of those systems. And in fact, I think this is a customer who's running with project CPU on, but no actual zIIP. So 20% of an engine is quite a considerable amount of crossover. Well, that's not so bad if you don't actually have any zIIPs. It just means they were going to run on GCPs anyway, but they would have been zIIP eligible if you had a zIIP. So service class level or report class level, you can look at zIIP utilization. Okay. Just a brief primer on velocity calculation, because it'll be significant in the next slide or two. The way we calculate velocity is using samples divided by using samples plus delay samples. So if you think about this, the bigger the delay is relative to using, the lower the velocity we achieve. So it's one way of measuring delay's significance. Well, I've used the word sample just now. For a velocity goal service class period, you can usefully use samples. So forget zIIP for a moment. You would expect for a service class period to get using and delay samples for both CPU and IO and a few other more exotic things, right? These are the sample counters that affect the velocity calculation. Slight sidebar here. You get the individual using and delay samples in workload activity report data, but you actually get, so you don't have to guess how to calculate overall using and delay samples, you get the headline using and delay samples as well. I suppose it's one of the ways of checking whether IO is in it. Now, with zIIP, you get, in addition to those samples, you get using and delay samples specific to zIIP. And it's useful to try and correlate the delay for zIIP that you see in the velocity calculation with the percentage of zIIP on GCP. It might explain behavior. It's, as we'll see in a second, not 100% one for one. The other thing to note is if you were saying to yourself, well, I'm getting no crossover, don't believe that that necessarily is a sign that all is well, because you could be getting delay for zIIP and still have the unit of work satisfied by zIIP eventually. So just going with the crossover number is really not a safe thing to do. So here's an example for a DDF workload. And I plotted really two kinds of thing on the same graph, which is a little naughty, but it's useful sometimes to do it. So the stacked bars are actually CPU numbers. GCP on GCP meaning stuff that never was eligible. zIIP on zIIP meaning stuff that was eligible to run on a zIIP and did run on a zIIP. And as we can see, a bit of green here, zIIP eligible work running on a GCP. What I've actually stacked alongside it as a line is zIIP delay sample percent. Now, actually, a more modern version of this chart would also have CPU delay samples alongside as another line. And the reason we would do that is because you might have delay for zIIP and not get crossover simply because the GCPs were also maxed out as well. So there's no guarantee just because you have a delay for zip that you're going to get crossover. You have to look at the GCP picture as well. So I'm kind of offering this as a composite way of quickly seeing how a service class period is affected. Okay, now the next key thing is understanding your exploiters. So exploiters come in all sorts of different shapes and sizes, and they leave what I consider footprints in the sand accordingly. They have, and this is the reason why you would care about that, different criticality levels. And that, just to repeat something I've said before in this presentation, really ought to be reflected in the WLM setup. So we have dependent enclaves, which run at the same, in the same service class as the address space they run in. So they are really dependent on the address space. And examples of this I've already mentioned, actually. DBM1, prefetch and deferred write, and log read and write in master in DB2. We have independent enclaves, and a good example of this is DDF, which runs in its own service class, separate from the dist address spaces service class. And in passing, I should mention dist really should be in the same service class as master and DBM1 and treated well. Then we have ZAP on zip, if you like, or otherwise known as the rest. So that's going to be things like ZAP eligible work that now runs on zip. So Java outside of JNI would be a good example of that. So, I mean, one of the key things here is, let's refine the statement about DBM1 address space being performance critical. It's a dependent on, yes, it is, but in particular, related to zip, it's a dependent enclaves for DBM1 address space that is performance critical from DB2 version 10 onwards, and likewise the dependent enclaves for master address space in DB2 terms. So I think you begin to get a flavor of why taxonomy of zip exploiters is rather important here. So this is admittedly from version 0 point something of this presentation long ago, but I think it's still a useful one to share with you. If you look at SMF30 address space data, you can get, and probably the most useful way of doing this is a shift level summary of zip exploiters, meaning summarizing over, let's say, daytime or some point in the batch, which is particularly troublesome. So along the top, we have a bunch of categories of CPU. And down the side, we have the address spaces, and I classified them according to service class and report class. Now, I'm not going to take you through this in any detail. Let's deal with the majority of this, which is the bottom. So here we have CTG batch, which is Kix Transaction Gateway. That's the program name for Kix Transaction Gateway. And all of that work is going to be other zip eligible, meaning it's not dependent enclave, it's not independent enclave. Now, half of the right-hand side of this is it is really about what the eligibility is, and the other half, actually more than half of it, is actually where it landed. So you can see, for example, that actually I can't see because there's something in the way. It's always the way here. That the CTG address spaces are all running zip on GCP. Actually, this is the case where they have no zip. So I just find this tabulation quite useful sometimes to work out what's going on down at the address space level. And obviously you can do this by time of day if you want to. No, I've lost the focus here. Right, and here is the example of this, again from the same time range, where I've taken a single DB2 version 10 DBM1 address space, and I plotted, the blue is the zip percentage of the address space CPU. The orange and yellow are the actual CPU numbers. So we find generally we're in the range of, I don't know, 70 to 90%, let's say, zip eligible. This is version 10, of course. But there are times of the day where the zip eligibility actually goes through the floor. And there will be other times, and I think the times are now, when more modern DB2s will have much more zip eligibility. So I think it's kind of nice not to just take a boilerplate 80% zip eligible number or 99% zip eligible number or whatever it is now, but actually see how it varies by time of day. Now, I couldn't say that's necessarily useful, but as I like to say, you know, today's tourist information is tomorrow's mission critical information when something happens that nobody expected. So there is a little bit of value here, I think, in plotting for some address spaces, the zip eligibility by time of day and a few other things. Okay, very briefly on projection, because this was originally a capacity planning presentation. Really, the main mechanism for existing workloads that don't get to run on a zip is the project CPU mechanism. And we've seen zip on GCP examples already in this presentation. The problem exists really with workloads that don't exist yet. So you have to use any sizing guidelines you can get, or maybe you have to see what your experience is in test or development and try and apply that, scaling up obviously into production. So there really isn't really very much that's going to help you in terms of sizing something going forward that doesn't already run. You also have to be a bit careful because, I think I've got the bulleting level here slightly wrong. Some adaptive exploiters exist, so they only try to use zip if you actually have one configured. Under those circumstances, if you don't have a zip in the LPAR, then project CPU mechanism is actually going to show 0 because it doesn't know about you know, what would happen if you finished a zip, right? So project CPU is a very useful mechanism. It has a few foibles in the categories I've just talked about. The other point I suppose I should make is that projecting into the future would be very similar, I think, borrowing new implementations of things as general purpose engine capacity planning. But it's really the working out what's going to happen that's the more difficult thing rather than sizing growth in workload. Okay, so let's switch gears a little bit and talk about performance topics really. So what I've seen a lot of configurations is everybody gets a zip, whether it makes sense to give them a zip or not. And I'm sure the emotion and the thought behind that is we want to scoop up every single bit of zip eligibility to minimize our software bill. And that's fine, and I don't dissent from that, except for I think you need to think it through in a more detailed fashion than that. So an LPAR with low zip usage really might not, it turns out, warrant any zip capacity at all. This is really a trade-off between lost zip exploitation, think money, and performance, also think money. You know, other LPARs on the machine might warrant better access to the zip more than this LPAR warrants access to the zip at all. In particular, LPAR weights need a special care. So one of the things when I was refurbishing this presentation early in the year that people from development kept telling me, and I think this makes perfect sense, was if you have a vertical medium or a vertical low zip processor, if it's not running because it's not dispatched on the physical, it can't invoke the needs help mechanism from general purpose engines or from another affinity node for that matter. So there would be a delay in other processors helping out an overloaded affinity node, or in particular, you know, zip, vertical medium or vertical low. That's not true of vertical high, because a vertical high is, and I'm still trying to find a good term for this, let's say quasi-dedicated. So it's always dispatched to the same physical zip processor. So there isn't an issue with I might not be dispatched and I need help, right? So having at least one vertical high in the zIIP processor pool for the LPAR guarantees that needs help is going to work as fast as it possibly could. So there's a real premium here on having a vertical high for the zIIP pool for an LPAR if performance matters. So that's one thing that people like Kathy Walsh and people in Poughkeepsie and actually in DB2 land kept reinforcing in my brain was there's a real premium on having a vertical high. If you can't, then you have to think very carefully about, are we going to get timely needs help happening? The other thing to bear in mind here, and that is all driven, whether you've got a vertical high or not, is driven by the weights. And you have to bear in mind that weights really are a zero-sum game. So LPAR A having too high a weight very much could prevent LPAR B from having a high enough share. So, there's a flavor here that says get the weights very carefully right for zIIP, just like GCPs, but for even more performance sensitive reasons. And it might even lead you to conclude that some of those small LPARs really probably shouldn't have access to a zIIP. That's a difficult decision to make, as I think I've given you the flavor of. The other thing is a zIIP dispatched in, for example, another drawer or a cluster, or in Z13 terms, a node, can affect processor cache effectiveness. So this is less of a problem with a vertical high because vertical highs tend to be assigned physically in the machine ahead of vertical mediums and vertical lows, at least the home addresses we're talking about. So vertical mediums and especially vertical lows, well, vertical lows could be dispatched anywhere in the machine. So, if you're running on vertical lows, then you're going to potentially affect the processor cache effectiveness, not only of the zIIP vertical low, but also of other logical engines in the LPAR. So, LPAR configuration really needs careful thinking through, especially the weights. I think we probably can skip over this one for brevity. So there are some performance considerations that need to be thought through, even if you don't think about Exotica. And here's quite a good one. So IIP on a priority used to be at an LPAR or ZOS image level. Now, with these two APARs, you can now specify it, and this is not that new, at the service class level. And what it means if you do it, if you turn IIP on a priority off at the service class level, it means it can't cross over to GCPs. So really this mechanism is designed to protect the GCPs from large zIIP exploiters such as Spark. Spark is a workload that can be very large and is highly zIIP eligible. So you might want to prevent Spark work from crossing over to GCPs. Similarly, it can use a lot of memory. So you can memory cap at the service level. This is really aimed off target now, but at Spark. Now, SMF30 has a flag for this, and even though this is a service class thing, SMF30 having a flag for this means you can report on this at the address space level, and indeed we in our reporting do. Now, I think one of the points here is it could well be applied to non-Spark work, as we shall see. So it could actually be a very useful tool to know about. So that's a little old now, but I think not many people necessarily know about IIP on a priority at the service class level. Okay, and here's one of the reasons why I think you might want to pay attention to it. So in ZOS 2.4 on Z14 or later hardware, you can run Linux on Z containers, Linux on Z containers for Z. By the way, that's not my wording. I actually got changed from Docker on Z by my friends in development, to run on ZOS. So back in January, there was an estimate there were about 3,000 Docker images available for System 390X. Again, that's not my term, which can run in these address spaces on ZOS. So basically, one of these address spaces contains enough Linux and currently Docker infrastructure to run the containers with the work in. You can have multiple of these application instances or containers per ZCX address space. And you can have multiple ZCX address spaces per ZOS LPAR. So there's quite a lot of mix and match topology configuration stuff here. Now, one of the key reasons for mentioning this is it's got a very high level of zip eligibility. So if somebody fires up ZCX address spaces and starts putting work into them, I think you want to know about it before it happens. And you're definitely going to want to measure their impact on the zip usage of both the LPAR and the machine. And you might well want to limit the ability or prevent these containers actually crossing over to GCPs, right? So this is the other case that I can think of where service class level IIP on the priority might be a useful thing to do. The other thing to be aware of is, suppose you have a container that talks DDF into DB2. That's actually a prime use case, and one of the reasons why you might stick, one of these containers or some of these containers on the ZOS LPAR, right? Because of the locality or co-location. Now, that, because it's DDF, I'm told, and I've not seen measurements yet, and I'm sure this is right, meets all the eligibility criteria for the usual level of zip eligibility for DDF work. So not only could these containers themselves drive a lot of zip use directly, but when they go to DB2 through DDF, they could well drive DDF zip eligibility. And obviously, it almost isn't worth saying, but I will anyway, DBM1 and master address space zip usage can also get driven up by this. So I really think you want to know if somebody is going to be putting ZCX containers on any given LPAR and actually measure their impact, and think not about prevention so much as control and configuration. Okay, so one of the controls here is how many virtual CPUs each ZCX address space can have. These map onto TCBs, and that really, the point about TCBs is if you've got 5 TCBs, you could drive 5 zip, up to 5 zips at once directly, without talking about the DDF DB2 thing I've just mentioned. So the controls and the number and what runs in these address spaces are quite important, particularly the number of virtual CPUs. Now, this is sort of drive-by with a subliminal message. So the subliminal message, which I'll make explicit, is there is important maintenance early in the life of ZCX. And that's a good thing, I think, that actually, from the get-go, work to improve performance for ZCX has been underway, and it's borne fruit. So the first one, OA59573, is an important APAR. It contains large page, meaning 1 meg and 2 gig page support, and also some zip optimizations. And there's a very nice article that Anthony Giorgio and Nick Matsakis wrote. And I just pulled out one quote from it, which is, in general, about 95% of the processing done in a ZCX appliance will run on a zip processor. I've just said ZCX, haven't I? Never mind. The other thing I should point out here is, which reinforces the point about 1 meg and 2 gig pages, is that a ZCX address space, at minimum, is a long-term page fixed 2 gig address space, right? So you need to do proper memory capacity planning as well as proper zip capacity planning here. And if you have the handouts, the links, the underlying links are live links So this planning for ZCX memory considerations section is a link you might well want to look at for that purpose. Okay. There's another APAR 0858296, also a live link here, which provides significant scaling and zip eligibility improvements by reducing the switching from zips to GCPs. And really, the bigger the container, the greater the benefit. You know, there are some very nice numbers with internal measurements at the 16 virtual CPU level. You know, 50% ETR improvement is rather nice, big ITR improvement as well. And the scaling is better. So this is another API you're going to want on if you're going to use ZCX. And ComServer has done some work as well, which improves, again, the ZCX network processing offload to zips. So there's a bunch, I mean, gratuitously and development wanted me to add these, and I think this is useful information if you're doing ZCX. There's a bunch of APARs here that people will need to look at. And in general, for ZCX, you need to have a fairly firm view of how to control zip usage and also memory usage. Okay, now switching gears somewhat. You know, when you build a presentation over 10 years, it becomes difficult to keep a structure. So you know, some of these things look a bit jumbled up, but hopefully they make sense. In DB2 accounting trace, SMF 101, which actually I'll be talking about a lot more in my Even More Fun with DDF presentation next week. There's a lot of information about zip usage. And I've just listed a bunch of fields here. If you turn on trace classes 1, 2, and 3, then you're going to get the headline buckets essentially at transaction or commit scope level, depending, for zip time, and broken down not just into in DB2 zip time versus out of DB2 zip time, but also to individual functions like triggers and stored procedures and UDFs. You also get a zip on GCP time, which my DB2 colleague tells me was broken, but I'm now told is actually fixed. So you could work out which piece of DB2 work, especially DDF, is suffering from zip on GCP time, in other words, crossover. And we'll see an example of this in a minute. If you turn on package level, you get zip time at the package level. Now, one of the interesting changes a while back was originally the zips support for DDF was a case of each thread was whatever percentage eligible. What's happened now is a thread either is entirely eligible or it's partially eligible. And in my code, which I will talk about next week, I'm pleased to say, I actually count a number of transactions in DDF that don't have zip eligibility versus those that do. So you can understand how the mechanism with what I think Peter calls the generosity factor actually works. I've actually got a question here, which I'll take right now because I brushed over SMT. The question is, do you recommend to activate SMT for zip or not yet? I'm not sure it's a matter of not yet, by the way. I am neither know nothing forward-looking, nor can I say anything if I did know forward-looking. It depends. So very briefly, SMT will give you, let's say, and this is hand wavy, I think the expectation is about 20% more zip capacity, and it will give you more logical threads, which could be good for queuing. That's nice. However, 20% more capacity means each thread runs at about 60% speed. So we have a trade-off here between the number of logical threads and the capacity on the one hand versus the speed of the threads on the other. So a good example which might drive you this way, I think, would be maybe it's DDF work, maybe it's DB2 work, because there are a lot of threads to queue, so you might want more threads than cores. that might drive you that way. The other way, though, might well be something like a highly CPU intensive Java job, where really the engine speed is what matters. And of course, workloads are generally a mix of those. So that's probably the briefest version of it depends, other than just saying it depends, that I can give you. So hopefully that gives you a flavor. And hopefully, by the way, you're all encouraged, because I answered that question with whatever quality I did, to actually ask questions now. So thank you, Guy, for that, that question. Okay, right. So as I said, you can tell at the individual package level whether it had zip eligibility or not. Now, this is an example which is slightly worsened by having to fuzz the names here. So I apologize for that. But here's the thing. If you are a DB2 thread that calls a stored procedure from DDF, if it's a native stored procedure, your zip eligibility flows through to running the stored procedure. If, however, it's not a native stored procedure, then that zip eligibility does not flow through. Now, here's an example from a customer we looked at. We had the opportunity to do this last year, so as usual, I took it, of examining down at the package level, and the stored procedure does run in a named package, as do UDFs and triggers. You know, I examined this from the counting trace. So hopefully you can see my cursor. The first one in the list, and I've ranked this really by GCP CPU. The first one, and my cursor's just disappeared. First one in the list, very little zip eligibility. I don't even know why there's any at all, to be quite honest here. And this is a non-native stored procedure. Next one, though, which is almost as much GCP. Thank goodness it's a native stored procedure, because there's a nice big, 60% or whatever zip CPU here, right? And the next one is a package that doesn't call the stored procedure with a similar zip eligibility, and in fact, in this case, usage. Then we have stored procedure, non-native, so not much, or if any, zip eligibility. And then we have, and this is the one, native stored procedure again. So, the counting trace down at the package level could be really handy in explaining why you're not getting whatever you think you ought to get in terms of zip eligibility for DDF work. And as a ballpark, I am seeing typically about 60%. But remember, because the mechanism changed from enforcing 60% to a proportion of threads are either all zip eligible or not, you won't necessarily get exactly 60%. And I do see variations. And this is a really, as I say, a really handy way, if you have the counting trace at the package level, of figuring out what on earth's going on. Okay. My sponsoring manager way back when asked me about zip to general purpose engine ratios and wanted me to put a slide in. You can see this is actually quite a short slide, which means I don't have a huge amount to say about it. Really what's important, as I said to him, and yes, I do sometimes push back a little on my management, sometimes a lot. What's really important is not the ratio really, but how the zip is performing. And especially as we've seen, how CPU stringent workloads perform. Now, he had in mind a case where there was 12:1 GCP to zip ratio. I think the ratio isn't necessarily bad, depending on what you're running, but what the real problem here is the one. So you get one-way queuing. So I would like to see more than one zip in an LPAR, but we're back to, are they going to be vertical highs or what do you want to call them? Heavy vertical mediums or not? I would take an unscientific view that somewhere in the region of 2:1 to 4:1 GCP to zip ratio is rarely going to be harmful. Right, and I've already said the bits down the bottom here, which is, you have to, when you're trying to work these out, not just look at the machine ratio, if you want to look at ratios at all, but look at the LPAR effects. And so I say often the answer will be, don't configure zips for this LPAR, because it simply isn't a good idea when you take it all into account. So that really just reinforces the point about if it's at all possible, try and have at least one vertical high for the LPAR. But zip to GCP ratios, I'm not sure really is a live heavy topic. Okay, just briefly on subcapacity general purpose processors. So in the case of subcapacity GCPs, the zip will still run at full speed. So for example, it's in the region of 65 to 75% faster than a 6XX GCP. The good news here is that zips run at higher capacity and faster than the GCP. The not so good news is that when you have work that runs zip eligible, but actually runs on the GCP, it's probably going to run a bit slower, maybe a lot slower when it crosses over to a GCP. The other thing here is if you take a DDF workload, as I say, some threads are going to be all zip eligible and some threads are going to be all GCP. So if the GCP is slower than the zip, then those threads running on the GCP will probably run slower than if they run on a zip. So we've just introduced some variability here. Okay, so how all this plays is going to depend on number of threads, CPU intensiveness, as I just said with the SMT thing. So actually SMT, to pick up on that question again, that might be quite handy for zips to counteract the slower GCPs if you have them to some extent. Now, if your GCP is 65 to 75% slower than your zip and your SMT to it, they're not going to match, but they might come a bit closer, and that might be handy in terms of variability. So, you know, SMT might be a reasonable thing for more cases where you have subcapacity GCPs than if they're all full speed GCPs. Okay. Right, and actually we've really covered SMT already in the question that was asked. Okay, let's get on to SRB. We've got a few minutes left here. I don't like the name SRB, I'll be quite honest with you, and the people I've talked to in development don't particularly like it either because of its reuse, okay? I'm not going to spell out system recovery boost here. And just for context, I'm not going to be talking about the other kind of SRB that we all know and love, right? So hopefully there's no ambiguity here. And I discovered the name for the new thing is recovery process boost. Now, RP to me is received pronunciation, which is a bit of a red flag as a name, but never mind, we reuse acronyms, don't we? I doubt anybody in marketing who came up with the term recovery process knows what received pronunciation is, but never mind. So the idea of SRB is that if you're shutting down and restarting work on the other side of a shutdown of an LPAR, you really want that to be as fast as possible. So what we do is we allow the zips on the LPAR to run non-zip eligible work during the shutdown and restart work during a specified boost period that you nominate explicitly in your operational procedures. And that will have no impact on IBM's software cost. And we will also at the same time, by the way, allow subcapacity GCPs to run at full speed, which also will have no impact on software cost. So that means you've got much more bandwidth, CPU-wise, to do the shutdown and the restart work. Now, that's the basic thing. If you go for something which is optional called SRB Upgrade, you can deploy extra zips on the fly in this process. Now, SRB is actually on by default for ZOS. For some LPARs, you might disable it. So for example, test LPARs where SRB isn't really part of the test you're running, you might want to disable it. You might not care how long it takes to recycle the LPAR. You might not want it to chew up zip that your production LPARs need to run. So that's SRB. Now RP boost provides short-term acceleration for specific recovery events, and I've listed some of them here. Now, the key thing about these two capabilities is, and I've alluded to this already, during a boost period, an LPAR could use a lot of zip. And that could be to the detriment of another LPAR, hence my comment about test LPARs. So you need to think carefully about how you manage control of zip so that, for example, a test LPAR being awfully quickly recycled doesn't up and bite a production LPAR. So there's some thinking. I mean, this is a very nice function, don't get me wrong, but there is definitely a set of thinking you need to do about this. And remember, SRB is on by default for ZOS on Z15. Now, you know, what I've just said about SRB and RP boosts is equally true of any large surge and zip eligible work. So you should have thought through to some extent, ideally, what happens if you know, let's say you've got a test DDF that goes crazy. You know, what happens in terms of its zip impact on production in a neighboring LPAR? So SRB, very nice, got some considerations. And I would say you need to assess how you choreograph shutting down and restarting an LPAR. Firstly, you actually need to do the start and stop, to start and stop the period. You probably want actually to assess with SMF30 for the relevant address spaces, you know, how long it's taken to shut down various pieces and start them anyway. Your automation certainly will need to change. As I say, there's this procedure, IAA SDBS, that you need to activate the shutdown boost. And I think you need to run it again to, or at least maybe there's a companion one to terminate the boost period. You probably want to automate around SRB's messages itself. Okay, now on the OMF front, the support in this APAR tells you what kind of boost you've got. Basically, in this LPAR, in all the 70X record types and also 70 subtype 1 will tell you about all the LPARs on the machine. I think the latter is probably more useful than the former, to be quite honest, although I like both. It was impressed on me there's a fixed cat that you really should keep an eye on, whatever the verb is with fixed cats here. There was another point that I think was worth making here is that during the SRB boost period, ZOS will automatically manage the reserved logical zips. So it'll bring them online at the start of the boost period, and it'll take them offline again at the end of the boost period to the extent it can, because it obviously can't go above the number of physical zips. The other point here is that RP is slightly different in that it can only bring online up to 2 offline logical zips. It's not all the ones you've got offline. It's limited in that regard. So quite a lot to think about in terms of SRB. So to conclude, and then to get to my friend Norton's question in just a second, if you only remembered 5 things, I hope they were: capacity planning for zips has become much more important. You need to pay special attention to what percent busy represents full. It's probably much lower than you might be expecting, and certainly much lower than zip, than for GCPs rather. You need to be looking really very closely at zip potential and usage down to the address space level. You need to consider LPAR configuration carefully for zips, including which ones get it. And I've given you some examples, and I've avoided giving 2 third-party software examples, which I'm very aware of, of exploiters. New ones can significantly increase the demand for zip, and actually in the DB2 cases, we've seen new behaviors for old exploiters. And I guess Connect Direct, by the way, the blue washed version is another example of that, can significantly increase the demand for zip. So that's the prepared material. After this, which I'm not going to go into, is a load of more detailed material from 2 great guys, John Campbell and Adrian Burke, on the DB2 front. So let me stray into overtime by trying to address these questions. Now, I've not read your questions, Morton and Paul, so if I'm not fluent, forgive me. Right, so Morton, you don't have a question, you have a comment, which was basically for test and development, you allow 1 zip, and for production, at least 2 zips. I don't know whether test and development, you really want the zips. Yes, as you know, and probably other people know, I've seen your estate, but it's been a while. It might be useful to go through the test and development LPARs and decide really, truly, hand on heart, whether they should have zips. Now, you may well be testing functionally, which might be a good reason for some of the test and development LPARs to have zips, you may actually be doing tests in terms of how much, you know, what's the performance like when something runs on a zip. But yeah, I mean, it's good to have a rule. I think, Morten, you're absolutely right in having a rule. And everybody needs to think carefully about what that rule or, you know, ways of deciding ought to be. So thank you for that, Morten. And I owe you a beer. Actually, I owe you several, don't I? One day there will be something rotten in the state of Denmark and it'll be me. Okay, right, Paul, let me read yours. I haven't read it. So just bear with me a second. Right, so your point here is, again, it's not a question, but it's a useful intervention, is, if I can summarize this, is that there may be circumstances where the behavior changes with high performance unloads various to increase, I think you're saying increase exploitation or even start exploiting zips. So I'm going to read back the point you make. Whoever is responsible for coding the switching rules, DBA or DB2 sysprog, really should be talking to their capacity planner. Absolutely right. I totally agree with that. Anybody who's ever worked with me knows I'm all in favor of people joining hands, right? And actually talking within the shop about things like this. So the DB2 guy or gal meets the performance whoever. I think that's absolutely right. And this is a very good example of it. It's also, I mean, the DB2 version thing is a good example of this. Although I think the DB2 version thing is almost old news. Actually, we're working with a very big Brazilian customer right now who is still wall-to-wall version 11. So who knows what version people are in DB2 terms, except I do if I see your data. So I think every software change, and this, as you've identified one, Paul, is a good one, is a reason to at least have a quick tick in the box of yes or no, this doesn't affect the zip picture for any LPAR, whether test or production for that matter. So thanks for that, Paul. Okay, so we are 2 minutes over. I personally don't mind that. Are there any more questions? Oh, hello, Stephen. Assuming you're the Stephen I know and love and have known for many years, I'm going to have to get back to you on that question. I don't quite remember the answer to that one, to be honest. I'm going to make a note of it, which is why you can see my bald patch.
Whilst Martin's taking a note of that, does anyone else have any questions for him that they'd like to post? Can wait a couple moments to give you some time to type.
Yeah, and what I will say is I've actually not seen, and I would like to see real data from around boost, because then I'd be able to say, look, this is the way it's actually working, which is sometimes interesting when talking to development when they thought it worked a different way. But I will actually ask. The guy in question I'll ask is Dave Sermon, who many of you probably know is an extremely good IBM distinguished. Is he DE still? He should be fellow, but he's a very good DE if he's not a fellow. I realize I can actually mouse over.
But, Martin, could you flick to the slide with your contact information on? Because then if anyone has any questions they'd like to send to you afterwards, we'll give them a second just to take a note of your email.
So I'm doing Soylent, right, I'm doing Soylent Green in reverse, aren't I? That's a possibly obscure, possibly not obscure cultural reference. So anybody who doesn't know who I am by now, oh well. Sorry, that sounds arrogant. I'm completely joking. Right, you can find me lots of different ways. You can't really avoid me. Again, it's a silly joke. Yeah, you can email me directly, or you can find me on Twitter and Facebook and LinkedIn. In usual places, and many of you already have, I know, and many of you I know.
Yeah, but think everyone's had a chance to take your email address. We've given everyone a chance for some questions. I will just post everyone a link to the session feedback in the chat. It should be there. If you could all take the time to leave us some feedback, we really appreciate it, and it helps us to run these sessions better for you all. And a big thank you to you, Martin, for taking the time to do this session and the other ones that you're doing for us.
So I was going to make one. Can I just make one brief comment? This is a presentation that I intend to refurbish on a relatively frequent basis, right? So this is certainly not take it or leave it, and some of you will have seen previous versions. And the reason why I labour that point is I'm very much open to suggestions on this material, and yes, it will evolve, and that's not me trying to present the same damn stuff next year. It will evolve, and I'm encouraging people who think it needs to go in certain directions to help me out. And this is where development helped me with SRB and helped me also with ZCX. So feel free.
Great. Yeah, we're always eager to hear from you all what you'd like us to have the speakers present on. So we're very open to hearing from you as to what you'd like to know more about.
And hopefully talk to many of you soon.
Yeah, hopefully talk to you all soon. See you all face to face soon, hopefully. And I think we'll leave it there and end the session there. Thank you